everyone, welcome to my channel. Today we will be discussing about the topic imperfection in solids. We have discussed in our previous session about the topic closed packet structure. If you have not watched that video, please make sure to watch that video. You can find the video link in description below. Now let's know what is imperfection in solids. We know solids are made up of constituent particles, that is atoms, ions or molecules. These constituent particles will be arranged in a disciplined manner or a particular manner. When there is irregularities in such arrangements, it forms an imperfection in solids. So these imperfections can be also called as defects. So there will be two types of defects in solids. Two types of defects. The first one is point defect. Second one is line defect. So what is this point defect and line defect means? The irregularities from the ideal arrangement around the atom or a point will be the point defect, and the line defects will be the irregularities from ideal arrangement in the entire row. Means the defect is found in a point means it will be called as a point defect. If the defect is found in the entire row or one line, it will be called as a line defect. We will be discussing only about the point defect, not about the line defect. So let's see what is point defects. So point defects will be classified into three types. That is stoichiometric defect, impurity defect, non-stoichiometric defect. Non-stoichiometric defect. So let's discuss about this one by one. The first one is stoichiometric defect. So this stoichiometric defect can be classified further into four types. It can be classified into four types, that is vacancy defect, interstitial defect, wrinkle defect, and Schottky defect. In these four types of defect, the first two defects will be found in non-ionic solids. Non-ionic solids means the constituent particles will not be ions. It may be atoms or molecules, but not ions. And the next two defects will be found in ionic solids. So let's know one by one. The first one is vacancy defect. What is vacancy defect means? When some lattice sites are vacant, the crystal will be said to be as vacancy defect. Means in an arrangement, the particles will be absent in certain places. Means the particle will be absent, so it will be a vacant space. This will be a vacant space. So obviously when the atom leave away a substance, the density will be decreasing. Density will decrease. And this defect can be developed when a substance is heated. Only when a substance is heated, the atoms can leave the solids. So these defects can be developed when solids are heated. So the next type is interstitial defect. Interstitial defect. In this defect, what happens is this will be the arrangement, means the gap between these, there an atom comes and occupies the space. This is the interstitial space, atom occupying the interstitial spaces. So when an atom is added, the density will increase. Density will increase. So this was about vacancy defect and interstitial defect. It will be found only in non-ionic solids. Next, discuss about the Frenkel defects and Schottky defects, which is found in ionic solids. Before learning this, let's know that in ionic solids, it must always maintain the neutrality. Electrical neutrality must be maintained. So they show Frenkel defects and Schottky defects. So what is Frenkel defect? What is Frenkel defect means? The smallest ions, the smaller ions which will be present, it moves from its original site to a interstitial sites. Means, for example, this will be a space of one ion mean. It may come and occupy here. It is an interstitial space. So this type of defects will be called as Frenkel defect. Here there will be no change of density. Only the place is changing. Neutrality also will be maintained here. So no density change will be found in Frenkel defect. And talking about Schottky defect, in this Schottky defect, the vacancy defect in ionic solids. It is a vacancy defect in the ionic solids. Means in order to maintain the electrical neutrality, what they do is the number of cations leaving the solids will be equal to the number of anions also. So your density will be decreasing. Density will be decreasing here. Means when you consider a solid, ionic solid, so this will be a solid. If one atom leaves the solid, the neutrality can't be maintained. So the number of cations and anions leaving will be equal, so that the neutrality will be maintained. We can give an example like NaCl, KCl, etc. So this was about the stoichiometric defect. We will be discussing about impurity defect and non-stoichiometric defects in the next video. So guys, if you have liked this video, please click on like button, and for more videos please subscribe to my channel.